So let's see what a complete solution would look like for example number 1. A lighthouse sits at the top of a sheer cliff. A sheer cliff is a very steep cliff. The top of the lighthouse is 33 meters above sea level. So I'm thinking the lighthouse must be up here. In this problem, part of the diagram's even already been provided to me. The angle of depression, so that means the angle that I'm looking down to a small sailing boat, is 24 degrees. Angle of depression is 24 degrees. Determine the distance of the sailing boat from the base of the cliff. So the base of the cliff is here, and the sailing boat is here. And I want to know the distance between the base of the cliff and the boat. And I want to round that off to 1 decimal place. Okay, so I've labeled up the diagram to help me. I'm focusing on the mathematical things that I know, the 33 meters, the 24 degrees, and I'm not worrying so much about drawing little pictures like of a lighthouse or something like that. I've identified a triangle and added in the things that I know and the things that I don't know, the things that I'm looking for, like the distance. Now I need to decide how I'm going to apply trig to solve this problem. The first thing that I notice is I don't know an angle that's actually inside of this triangle yet. I need to figure one out. One way to do that would be to say, well, that horizontal line and this horizontal line, they're parallel. If this is 24 degrees, then this must also be 24 degrees. Some people might also say, if this is 24 degrees, these two angles together need to add up to 90. So this angle inside here would have to be 90 minus 24, or 66 degrees. It doesn't matter which way you go. You could use either one. I'm going to stick with 24 at the bottom. So if I'm sticking with 24 at the bottom, that means that 33 is the side that is opposite the 24 degrees, and D, the distance that I'm looking for, is the side that is adjacent to 24 degrees. Because I'm using opposite and adjacent, I'm going to choose a trig ratio, which would be tan. So the tan of 24 has got to be equal to the opposite side length, which is 33, divided by the adjacent side length, which is my unknown distance. Okay, so the main two things of my problem now are done, and I can get on to doing some calculations. So I use my calculator and I figure out that the tan of 24 is 0.44, 0.4452, and that's 33 divided by D. Intuitively, I know that if 33 divided by some number is like a little under a half, this number should be a little bit bigger than 66, a little bit bigger than twice 33. Formally, I could say D is 33 divided by 0.4452. So D has got to be equal to 33 divided by 0.4452, which is 74.1 meters. 74.12, but we're going to round off to 1 decimal place. So 74.1. I'm going to just write down a couple that my calculator gave me. It's a 1, 2, 3, 9, blah, 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 and make a concluding statement that says, therefore, the boat is about, and I always kind of qualify myself with an about, because I'm rounding things off, and that's going to leave a little bit of error. So the boat might actually be 73 meters from the base. It might actually be 75. Since I'm rounding off, I'm going to say it's about 74.1 meters from the cliff.